So the first thing we need to do is have a brief discussion about the .NET framework itself, and then we'll dive more deeply into using Visual Studio. So let's look at what our agenda is. A few of the things that we're going to talk about are why the .NET framework. What is so innovative about the technologies comprised within this framework? We'll then look at the .NET architecture itself. We will need to understand how it's constructed and how it ultimately delivers the application services that we need. Finally, we'll look at language support in .NET. This will be kind of a nice segue as we move toward the .NET framework within Visual Studio. So why the .NET framework? Well, a couple of things. Greater programmer productivity. One of the most important things to a programmer is that she or he be able to reuse code. We spend a lot of time reinventing the wheel. It'd be hard for me to describe how many times I've had to recreate the same classes to do the same application tasks. And I even get emails from acquaintances. They'll say, do you have some software that will do the following three things? And I think to myself, yes, I have that somewhere. And probably there are hundreds of programmers around the world who have it. But it's really difficult to reuse given the way we design applications right now. So we really want to make programmers more productive and stop obligating them to reinvent the wheel over and over. The other thing is the internet has moved from being a novelty, and even though there's been a slowdown in the .com craze, we still have a very strong infrastructure there. A lot of companies and organizations have spent huge amounts of money creating better pipelines to the internet, increasing the capacity of what they can do on the internet. So we now have this wide area network, this super WAN, that is ready to accommodate applications that are more sophisticated and that can expand in more innovative ways. So how can we leverage that? It's just a resource that's still there and we haven't really tapped it properly. The other thing is we need better language support. Some of the languages that we're using don't really fit with the way we're programming now. And Visual Basic for years has been a real powerhouse for a lot of Windows developers. It's revolutionized in many respects the way we do Windows programming. On the other hand, it has some pretty significant limitations. So how can we make that better? And how can we make it easier for people who maybe aren't familiar with the Visual Basic syntax but come from a C background? How can we make it easier for them to get in on this game, to work with these technologies without having to completely relearn everything they know? The other thing is, how can we make it so that if we design an application, we don't have to have all of it done in one language, and if we do have multiple languages, it's sort of seamless construction of the application between languages. So that's another thing, cross-language development. The last thing is we need a platform that is going to scale. Internet applications are designed so that they can scale to hundreds and thousands of users without having to go through some of the complexities that we now have to do in order to try and make an application scale. So what if we were to design a framework from the ground up that would allow us to scale? So what is the .NET framework? It is a multi-language development and execution environment. So we want to be able to create software. We don't want to have to worry about the language of choice for developing that application. And we need an application runtime. And that's where the execution environment comes in. Not only that, but it's also a strategy. So .NET, in addition to being an actual set of technologies, it's really also a concept. It's a way of thinking about the way we create, design, and execute applications. It's a way of rethinking how we do distributed applications. Up to this point, we've been doing distributed applications using technologies that in some ways were not designed to be used for distributed applications. And in other words, they were. So they've been extended and augmented to accommodate distributed applications, whereas .NET from the ground up is designed for distributed architectures. The other thing is that .NET is based on non-proprietary standards. A lot of people say, well, you know, if it's coming from Microsoft, it's, you know, rip and replace, it's monolithic, it's, you know, lockdown strategy. If I start down this path, I have to use only Microsoft. And this, I don't know if that's entirely accurate. In some ways, there are things that Microsoft does to lead us down a path to a lot more of the applications and tools that they offer in their overall value proposition. But in many ways, their platform and the server products and development tools and so on are really open to a lot of other applications and tools and platforms and so on. So .NET is that especially, because .NET is based on standards like XML, it's based on standards like SOAP, it's based on standards like HTTP, using those standards to provide this infrastructure. Most notable about .NET, I think, is that the consumers of .NET applications can be on any platform. And this is very, very powerful. So if I were to create an application today, put it on a server, using Visual Studio.NET, the consumers of that application, especially a web application, could be running any web browser or be running on any platform they want. They can then consume my software services. That we will be spending a fair amount of time talking about as we work with Visual Studio. This is a little summary of the .NET framework itself. We'll be spending just a moment talking about each of these components. At the bottom, you'll see the Common Language Runtime. This element right here is significant because what it provides is a common runtime for all of the languages that will be used. So depending on if you were using C# or Visual Basic, no matter which language you've used to develop the application itself, it's still going to have the same runtime to take an intermediate language, and we'll be discussing that briefly, an intermediate language, and turn it into execution instructions for the platform upon which it resides. You can see at the very top that this is where your applications live. So you have a web service, or you could have a Windows application, a web application, depending on what type of application you've created. And they use what are called the base programming classes. These base programming classes are essentially the APIs used for doing things with your application. Here are the three core elements of the .NET framework: the Common Language Runtime, the Unified or Base Programming Classes, and ASP.NET. Let's look at these a little more closely. Common Language Runtime. How it works is, no matter which language one has used to develop an application, it is compiled down to what is called the intermediate language. This is a language, it's actually fairly readable. You can look at actual output from the compiler of the IL, but it is functionally the same no matter what language you used. You can see there are three languages here that are in bold: VB, C#, and Visual C++. If you're using .NET, these three languages come with Visual Studio.NET, and they are already .NET compliant languages. These are the languages, our current or possible languages that could be used to create IL. The IL then is executed by the CLR. The CLR could be ported to another platform. It's not clear yet whether Microsoft has any plans to do something like that, but it could be done. And what is intriguing about that is that the CLR could be ported to another platform a lot more easily than, say, the COM runtime could. So yeah, I think it's reasonably likely that it will be done. And there have already been some rumors and other information has been passed around that this could happen. And ultimately, we'll just have to see what happens and wait until the marketplace speaks. What is important, however, is that Microsoft has submitted the CLR as a standard. Not the complete CLR, but a portion thereof as a standard. The intermediate language then is CPU agnostic because there's an abstraction layer that hides the IL from whatever the actual runtime platform is. The IL instructions include logic instructions, stack manipulations, all of the things that would needed to be used for memory management and so on. There are some .NET utilities for working with the IL directly. These are pretty interesting. There's the IL ASM, that's for assembling, and there's also one for disassembling the IL. Here's how the CLR and the just-in-time compiler work. So at the very top here, we can see we have different applications: a VB.NET app, a C# app, a Visual C app, maybe an application written in Python. And then these are compiled down to what is known as the intermediate language. The Common Language Runtime is responsible for taking the IL, and it uses a just-in-time compiler to turn it into native code and execution instructions. So The CLR is this runtime, but ultimately your application has to do something. And this is where the programming libraries, the unified programming libraries, the base classes, there are some different names that have been used for them. These base classes are the APIs you would use in designing your application. In Visual Studio, all of the API calls you make to do basic things like open up a window, resize the window, to do database access, to when you do web services, to work with your controls and so on, these are all done using well-documented APIs in these programming classes. No matter what language you're using, no matter what project type you're creating, you're going to be using these. They're hierarchical and they're inheritable. So they're arranged in a very convenient kind of folder-like hierarchy, if you will, with little nodes that drop down into other nodes. And this is a way that's very convenient for people to look through the APIs and find what they need. It sure beats looking through text files to look at API calls. All developers are using these same APIs then to expose the underlying platform. One of the great things about these is that they do not require registration in the Windows registry. They're fully self-describing. And when we talk about assemblies in Visual Studio, we'll understand that a little bit better.